Good morning. Assalamu alaikum. Thank you very much, Roger, for the introduction. As Roger mentioned, that we know each other for last 1992 when I just got an A&M, and he came to attend one of our courses, and since we got acquainted there, and since then we know each other very well and doing a lot of courses, training program. I do also at Texas A&M, a lot of training, short courses, 5 of them, 2 in food area, 3 was in aqua feed, pet food, and general feed, and next coming up in February that we will do it. Where before COVID, we did 100% in person. During the COVID time, we got virtual. No, it's a hybrid. Therefore, if anybody interested, I can give you some more information. Since we have started late, therefore, I will be happy to talk more in case you want to learn more about the courses. But at this time, I'm going to focus on some of the recent innovation, what happened in the aquaculture industry, and especially in aqua feed industry, and how that extrusion is working there, technology with all the new innovation. As you know that right now, it's time for AI, time for everybody trying to do it, everything from most of that gadgets. Therefore, there's quite a few things that happen. Therefore, today I'm going to talk about some of that most noteworthy development that we talk about: smart extrusion, energy efficient, floating sinking, slow sinking pelleting, of course, functional feeds. We talk about microencapsulation, low temperature, high moisture extrusion, some alternative protein sources, and personalized nutrition. All that things are happening in aquaculture. And I may not have time for that, discuss all the detail, but I try my best to do that one. Recent innovation we call smart extrusion, and what is that? What is smart extrusion? Of course, that's why we want to discuss that. Basically, it's a real-time monitoring and control. In this case, the AI that people are using now, they can monitor temperature, pressure, moisture, and screw speed to maintain. Therefore, you have individual control of every single thing that you can measure it. You don't want to go 1 degree higher or 1 degree lower. You don't want to add any 1% extra moisture or lower, because that's cost energy. And also that's going to cost you a lot of drying after that, and also things like that. Therefore, no, we have this AI system where they can unplug that one, and we can get exactly what we need. That will be our temperature, pressure, moisture, and screw speed to maintain that. Also, AI algorithm can automatically adjust setting of the compensate the raw material. If you get raw material, which is a little bit variations, because we do get a lot of variations there in the feed rate, and they can detect the moisture fluctuation. One day you have soybean comes up, maybe moisture around 12%, other than 13%. If you use that AI algorithm, it can basically calculate all the fluctuations and then give you exact what you're looking for, the temperature, the moisture, the pressure. Therefore, basically, we have this one. You know, remember that we have to go manually to do adjusting everything, not anymore, because the AI will predict that one. Any moisture, any variable, you have raw materials coming up, one day high fat, low fat, other different things, it can automatically fluctuation that can adjust that one as well. Also, we can predict by the modeling all the characteristics of that, what kind of texture, expansion, density, we need it, we can predict that one through the AI. Therefore, what we can do here is to put all the data into it, and then we can get all our input there, and we exactly know with this recipe, with this, all the processing condition, everything, what kind of texture we're going to get it, what kind of expansion we're going to get that one with that, very easily with that one. Also, it's very interesting that computer visions and AI can detect any defect before you go steep producing. Let's say if your color is not the same, your shape is not the same, your size is not the same in the real time, and then it will minimize the off-spec, because you realize that, okay, you made all the things, and it's not floating. You made all the things, say, oh, this is not 3 mm, it's 4 mm. You have less expansion, more expansion. But we can do it in real time, all the off-spec, they can detect that one, and then, of course, save you all that, because we can predict consistency and the quality control with that as well. Okay, also with that, what we do it this way, that we can have our pellet size, nutrient distribution, improve animal performance, because we are looking into a consistency. We don't want to make the product, one day it is high nutrition or high moisture, other day is different, other day different. We want to make sure that it's 100% uniform all the day, every day we make it, and that will basically help to make sure that our animal performance is much better. We reduce the waste as well. So this way we don't, we produce consistent quality product there as well. Also, it can help us to reduce that downtime. What that means is that in this case, we have predictive maintenance powered, but AI can detect sign of wear and tear. Therefore, if you have extruders coming up and there's a lot of wears in it, and wear and tear happening, everything, you basically will tell you that, so that you can have an issue with that. You can have screws, motor, die head, anything before they stop. Really what happens is that sometimes we can see that your screws broke or closing to break, and then you shut down the machine, you have produced a lot of product. In this case, basically, it will predict it and sign of wear and tear, and then it will let you know that that you need to fix that or you to do that maintenance before that one. Also, lower energy, as you know that everybody talking about energy and cost reduction, and this is the best way to do that. Basically, it can help you to heating and mechanical energy input. We don't want to add too much energy into it. We don't want to less energy into it to compromise the quality. Therefore, basically what it does is it gives you exact prediction how much energy you will be using that so that you can have a lower energy efficiency, consumption. You don't want to go a little higher, a little lower with that one as well. And also formulations. As you know that raw materials come from the field, it has variation every day because of weather, because of the environment, where it's grown, how they are harvested, how they are processed, how they are shipped. There were a lot of variations in the byproduct. Someday the byproduct have more starch, less starch. Someday we have byproduct have more fat, less fat. But this one here is basically help you to process different raw materials. And you can plug all the information and you can maintain the quality, and then it will help you with that one as well, the flexibility with the extrusion there. Cost-effective recipe. Also, you can help to formulate the cost-effective blends based upon the available ingredients. Let's say one day you have a fish meal available from one source, other day you don't have it, or you want to use some poultry meal, or you want to use something else, a soybean meal, and it has a, cost is more expensive one-time raw materials than the other one. You can basically do that one and raw material flexibility-wise, and then it calculates.
Hey.
What's that? I think that's something.
Hey.
Okay. Also at the same time, we have a data. As you know that everybody talking about data, we have to have a data logging system, and sometimes we have operators, they can write down something, and then sometimes they forget, they do that one. This case, a platform track all the process variable. Every single thing what you do it, you have recorded that one, and this way you have correlated them with the product quality data, because you have whatever you put in here, from raw materials from there everywhere, and you're processing it, all the steps, you need to have data, and it's not easy for the operator to get all the data manually. Therefore, if you use our data logging for traceability, it will give you what was the raw material came out, what temperature we processed, what was the preconditioning temperature, what was the preconditioning moisture content, what the RPM was there, what was our moisture content there, what was the pressure there, what was our expansion there, and therefore it's basically what was the pressure. They will give you all the information there, all the way to down there. Therefore, you have all the data you needed from that run. Also, it helps you to simulate, of your new recipe. Let's say you want to try a new recipe, and therefore it's faster development. What we used to do in R&D work, we have a raw material, we want to develop some new recipe, it takes forever, because we are trying to get some raw material in one way, another way. But this here allow us to do it. We can simulate our extrusion outcome, new formulations, reducing trial and error, because every time you run it, it costs money, and you don't want to do that. Therefore, basically, what you do here in this case, you will reduce your R&D work, and you can basically get it very easily, your new product there, because of that simulation. And what that means is faster product development, a shorter time to the market. Therefore, we can do that one with that, commercialize your product, whatever you're making it, pet food, aquatic feed. It can help you to do the market very quickly, rather than waiting for that, because your R&D is done very quickly and you develop the product very quickly as well. And of course, waste reduction. You can minimize the work, your rework and reject by detecting the AI early enough. We can reduce that all our production of waste and non-compliance byproduct beforehand. Therefore, we don't have to spend all that money there making the product, then it will be rejected later on. We can basically do that one also with this process. Also, it helps you to basically, with the waste reduction means also it better control the ingredient processing. What that means is that we have a processing conditions that can help you to overuse or spoilage ingredients as well. Therefore, you can do that AI system there, and you can control your ingredients. You want to see if this ingredient was spoiled, if it was overused, whatever that is, the limit, and then you can use that ingredients to optimize your, basically your formulation there. Therefore, to just summarize the AI I talk about very quickly, basically how the intelligent and alpha can enhance our extrusion operation. Basically, just doing by it is like a higher efficiency, better product quality, lower cost, faster innovation, or more sustainable operation. Therefore, basically, you will see that one here now that it is coming up. Next is going to be about your floating sinking, slow sinking, pallet customization, that you can see different pallets are requirements that there sometimes we need it float, we need to do it sink, we need a slow sinking, all can be done there. And how we can do that? We have a different starches. We can manipulate the composition of the starches. We have some encapsulation techniques. We have some twin screw extrusion. Why it is matter? Because different species require different feed behaviors. Some of them surface feeders versus the bottom feeder. And basically what we do here is we have different starch, and then we can manipulate that, see which one is going to give us the floatability, which one is going to give us the sinkability. Therefore, if you can see here that we have a starch here, and wheat starch, maybe it's a fat substitute, binding agent, texture improvers. This is a corn, that's their property, the high temperature stability, thickener, binding agent, potato starch, tapioca starch, rice starch. These are the characteristics. And what we do is we take and pick some of the characteristics from each of that, create some of the formulation which will help us to either develop, float, or sink, whatever requirements are, we can do that from here. Therefore, this will that we will get exactly what kind of expansion we're looking for, what kind of things we need. We can have all different kind of starches that we can, some of the cross-linking, some of them are, we use a different reasons, and then we can create some of that, our required product there as well. We also see it encapsulation coming up very quickly now. Basically, it is where you can add some of the prebiotics, probiotics, and all that kind of stuff in that. And there's the techniques coming up where you can use some of that in this, chambers there. And again, if you want to learn more about it, you can talk with me later on. But there's a lot of encapsulation of the feed, very special feed. That's also that industry is using it now to improve some of the product there. And then we have also advanced extrusion system. If you know that there was basically single screw extruder that has this much window, then we got twin, which was this much window. Now we have, even with the AI, all that, our window is getting bigger and bigger. Therefore, you can see there are different extruders. They have different ranges, operating ranges, depending upon what you want to make it. And you have seen a lot of different innovations in extrusion technology that is coming up there as well. And what is the recent innovation? That means reduction. And of course, our energy and waste, process efficiency, equipment efficiency, and all the recovery. That we don't want to waste any of the heat in that process. We will recover every single thing from there. And if you look here, we have a multi-stage or high-efficiency preconditioner. It used to be a very simple preconditioner, now but we have very sophisticated preconditioner. We have improved screw design, and we have also wastewater heat treatment system as well. Impact is that it basically reduces our operational cost and also carbon footprint of the feed mill. Again, you can see it, a multi-stage preconditioner. Again, I'm sure some other speakers are going to talk about it. I'm not going to talk on that one. There are different kind of preconditioner which is available depending upon your suppliers, and they all have a more efficient way to improve your productivity. Also, we have very special design of the screws that can give you more life on it. And then, of course, they also reduce less energy. That's also available. Then we have some of the waste heat recovery system. If you know, in the past, we used to have all the waste up there and then go to the contamination there. Not anymore. Now we have a recovery system there. We recover all that, and then we reuse all the fines. Also, other innovation is that where we used to, the preconditioner, we have it water going separately and steam going separately, but now we have a system there where we are injecting steam and water together, and therefore we can do it, and then there's a lot of different benefit there because it gives you much better cook as well. Steam comes there, water comes there, they both combine together, and then it goes to the system. There's other things that. Also, water stays inject together, common part in the preconditioner. Again, this is your preconditioner here, and then you have a steam coming up and the water coming up, and then you can inject both things together into the system, and that gives you much better result. And again, this is just showing you that system there, the new one, the water and the steam that goes there in the extruders, in the preconditioner, and they will help you to do much better job in the cooking. Again, this is in the production. You can see a steam water mixing unit system. It's a single port. and eliminate manifold, valves, pipe, hose injection, reduces the maintenance requirement, reduces the replacement cost, fewer obstruction. Therefore, right now you have just one injection here, therefore you don't have to worry about steam well got plugged up, water got plugged up, therefore you have less maintenance there, and then also get better result. Also, it is automatic blow down condensation, that you can do that one. Of course, you can have a startup, waste reduction, and of course, it will also help you to, as I mentioned, that some of the injectors got plugged up with the steam. It will give you much better result. And you can see here, it is before, it's after, and it will help you a lot because you have before have a lot of different injection port here, but not anymore here. You just one injection port for the steam because now we're mixing together. Some other benefit here, as I mentioned there, you can see here, again, both combined. In the one process flow diagram, static mixture to provide the mixing, higher cook level, reduction in steam escaping from the preconditioner. Also, we call it vent control system now, where we can basically get all that vent steam and also our fines from there. This is the vent system that you can see it. That means integrated heat exchanger device connected to the top of the preconditioner, where we collect all the extra steam and the water from there. How that works in the preconditioner here, we put that one vent, and of course it collect all that, and then after that we can recycle it, we use it. Again, this is just to show you that design there, and it help to reduce our incidental condensations, eliminate fine particles, reduce the risk of microbials, contamination, environment, all that stuff. Again, this is some more benefit, closed loop systems, and of course warm water discharge to preheat the process because we're not wasting the water anymore, and created a closed loop limited wastewater extrusion process there as well. Just to show you different parts, the design, which I think everybody who is in this area will know that. It's just basically different parts of that. That's where you collect all that cold water, that's where you collect the warm water discharge, and you can remove the cap, and then of course you can use this one as one of the recovery system. Also, we have closed loop system. What that means, that basically is that where we are heating and cooling in the same area so that we do not have to waste any of that and maximize our energy. I don't know if everybody sitting here, Roger, I don't know if everybody can see here or not, because I'm standing here. Therefore, this is a closed loop system here, and this one here is basically what it does is it reduces your wastewater, a more efficient control system. You have set point. So basically what you do here is you can set on each or different zone here, temperature, whatever you're looking for, and the closed loop system there that you can control all that water, and that if you need it, whatever temperature you're looking for each zone, you can adjust that easily, and then you can do with that without any problem, and therefore we much better energy efficiency with that process. Also, the last one I think is we call a shutdown system, where do you have some kind of tanks and all that after every run. If you know that, it takes some time to clean up and everything like that. In this case, you have this shutdown system oil that you can run it on the end of the extrusion process run, and then of course it will flush it out your product, and then of course it will be just an oil pump injection and with the flow meters, and then it will just on the end of the runs, you run this one, and this will smooth out your barrel screws and clean up very easily, so that when you start again, there's no any issue with that. This shutdown oil system is also available in the new innovation market. That was kind of some of the innovations we're talking about in the area of extruders, and there are also some of the innovation that happen in the aqua feed. We see a lot of different things. We have seen a lot of functional feeds, and that people are using it with the co-extrusion and microencapsulations. We're using some alternative proteins as well, oil sources, and also we've seen some of the bioactive and enzyme fortified feed as well. Basically, this is a way that you can get your functional feed via co-extrusion, where you extrude something, and then also you can bring some other your component into it, and you mix together, and also you can do some microencapsulation there also. And this option will give you adding of the probiotics, of course, microencapsulation ingredients, vitamin, medical thing like that you can use it. Benefit is that if you're looking for gut health, diseases, resistance, stress tolerance, and this is where we use that kind of product there as well. Some alternative protein and oil sources. In this case, we have gained a lot of innovation. We've seen it. We have seen a lot of insect meals, algae meals, single cell proteins, they're all coming up in the system now. And of course, challenge is going to be these ingredients require precise adjustment, temperature, screw configuration, pressure to maintain pellet quality. A lot of people doing some of the trial, and they are working on it. But this is getting also very much attention in the aquafeed industry because of the protein. Fish meal is always expensive. Therefore, they're looking some other, and there are quite a few work being done on using some of that insect protein into the aqua feed as well. Again, some of the bioactive enzyme fortified feed, the trend is that some of the enzyme inclusions, phytase, protease, to improve the nutrition. Ability is that how can you control that other than you do the encapsulation, you will destroy all that in the extrusion process. And therefore, in this case, we have to go through their different process and then maybe do at a little lower temperature or do some of the microencapsulation there and do that one. And just to summarize that, summary tables and innovation area and key benefit, as I mentioned there, you have AI and of course in the extruders, real-time control efficiency, pallet buoyancy controls, specific species feeding, functional feed, high immunity, health immunity growth, alternative protein, sustainability, cost effectiveness, energy saving, lower energy, enzyme, all these are things that we see it in the innovation area. With that, I still have like 2-3 minutes in case anybody have a question, but I will be here rest of the whole day and we're running the show in case you have any question. But is there any question right now, quickly I can answer. The question is basically, what is optimum temperature in the preconditioners? It all depend upon your recipe. We can go all the way even 90-95. We can go to 70, depending upon your recipe, what is inside the recipe. Are you scared you destroying your enzyme, a bioactive and not you're talking about it? Then we go to 70. But some of the application when we have an ingredient which is very high to cook, high to process, we go even 90-95. Therefore, depending upon your recipe, you can adjust your temperature. That's what you tell that each of the recipe will have specific precondition temperature. Therefore, you not just generalize everything. You just put on the very specific for each variety. Any other questions? If not, thank you. I'm going to continue. Our next talk was about pulverization, and our speaker got a knee surgery, and doctor told him he cannot travel anymore. And because he has a knee surgery, he sent his presentation, which is grinding and all that, and I'm going to give that overview, not go in details, just in 5 minutes before we start the next speaker. Is that okay? Okay, this is basically presentation from renal engineering. That speaker, as I mentioned, that has a surgery in the knee, and he was planning to come, but doctor told him not to travel that long. And basically, it is about grinding, but it's not just a regular grinder, it's a pulverizer, which has a different technology into that one. And therefore, basically, just talk about why you want to find grinding. You do not need a grinding for each of that recipe where you need to have a pulverizer. You need to grind when you're going to go very specific need for that. Otherwise, you have just regular grindings and everything. And different method, the design, we will talk very briefly here. Grinding basically is that where we have when you make kind of, we call it wheat flour, fineness is based upon the percentage of particle which is less than 150 microns. And of course, for aquatic feed, fine grinding generally considered 80% less than 250 micron. And therefore, there's a demand there for the aquatic feed when you go to less than 1.5 microns, 1.5 millimeters, and less than that 1 millimeters, you need to have fine grinding. Otherwise, you have a lot of issue with the plugging in the extruder. And that's why the people are start using it on pulverizer. But remember that pulverizer is very expensive and a lot of energy into it. You don't want to use that if you don't need it. And then this is just to show that some of the system, they can use it to sieve analysis, that they do that one. And again, here is that different kind of protein starches. When they separate them, grind them, you can separate them easily. That's some of the way that we do it, protein and all that kind of stuff. And starches we separate with just a pulverizer. And you can see here the difference here. It's an identical feedstock. One is ground, one is pulverized. And you can see here the difference. And of course, it is very, very fine ground material when you do a pulverizing. And pulverizing, of course, will take some extra energy into it. And also, if you can see here, sometimes we change the colors of the product because when you grind very, very fine, the inside comes out, you increase the surface area with the pulverizing. And then, of course, this is that just advantage that it can have much better cell open area, so the steam and water can go very easily inside, and you can cook it. And also, there's no any more plugging come up there as system there. Again, this is just a different definition of that particle size, and of course, volume of powder. If you want to calculate that one, surface area, you want to calculate then specific. By the way, everybody who registered will get a PDF copies of the presentation. Therefore, if you have any question, You can always talk with the speaker, and also you can email me, and I will be happy to help you with that one. The particle size matter because you need to make sure that it is small enough so it can open the dye area if you're going to make it. Otherwise, you have a lot of issue with the plugging, which we see it every day. Also, you want to make sure that it is surface area is big enough so that your water and steam will go inside very easily, and you can cook that very properly with that, especially when you're making a very, very small product. Again, why grind fine? Number one is that, as mentioned, it improves your digestibility. Of course, you can increase your throughput, and of course, less wear and tear on your extruder, because extruder is not grinders. If you have coarse material putting into it, extruder has to spend some energy to grind the material. And when they grind it, you're losing a lot of productivity. In this case, the fine grinding basically will help you to make it much better efficiency. And of course, your surface, your palette look very nice and shining, and it will be that consumer want to buy that. It's not the fish going to have any issue with the rough surface. It's the consumer who's going to buy it. And also it reduces that your fines. It reduces your all the things there that you will see it. And that's why you want to make sure that you are grinding fine. And mostly what we are trying to do here is most of the application we see that fine grinding, especially will be in shrimp feed, tilapia feed, eel fill, larvae, some pet food and treats, and you see a very unique, nice surface, that's where you use it. And of course, some of the pet food additives that you want to use that fine grinding as well. Example, again here, he's trying to give the example where he used the high return of the investment because he's using that one. And of course, it raised quicker because of more digestibility and all that. And of course, much better feed water stability due to the eating habits. And then of course, it helped to make it better return from there as well. This is just equipment design. That is an air swept pulverizer that they use this one techniques. In this way, there's no hammer, there's no sieve in it. It is a material which comes and hit on different plates here. If you can see in this case, you have materials coming up there, and the material will hit, and this bar will be, beater plate will be hitting there in between that, and keep circulating it until it goes there very fine, and that's where you do it. And then of course these are the internal plates there that run very fast, and then this is one when you run very high speed, and then it does that fine grind there. This is the common system where you can collect with all the materials comes there. This is exhaust fan comes over here. This is your feeding materials go there. Then you have cyclone where you collect all the materials into it. Again, this is the same showing a closed loop system there that they have that one, they use it. This is that small scale that if you're looking for that, just to show the idea, this is basically your pulverizer there, the cyclone, and of course the dust controller that can go there and collect everything. You need to make sure that you design it. You have to have a frequent inverter required to change the mill speed. Therefore, you have to use some of the battery machines there, battery motor there as well. And these are just advantages, some of that. And you can see here again, screening or cleaning is recommended prior to that. Of course, if you even using it, pulverized material, you will see we're making shrimp feed, you must screen it, and you have to, otherwise your motor dye will be plugged up there. And of course, particle size is very important. It's just talking about the coarse materials. And of course, if you are using that one, you want to make sure that it is properly grind and go through the screen. And by screening it, you can reduce all the chances there that you will not have that issue with anymore when you're closing that, and making the pallet on the end. Some of that materials they're using it also is high protein plant-based materials that they have used that one right now. They are using a whole soybean actually with the 18% fat. You can grind that easily with the pulverize that one. And it's, also some other materials they're using it. Process maintaining antioxidant, reducing the starch throughput classification. And of course, they also grub and algae and all high oils. They can do that with this kind of machine. This is that in our pilot plant that we had that one there. It's a small pulverizer, and you can see here that we are using that one for our production run. Again, this is where you collect your materials there, and the cyclone comes in, and you will collect that one here. Again, this is just a demonstration going on there that we used to do that in our pilot plant before COVID. Again, this is the hopper that you can put whole soybean into it actually, and then you can see the ground material just to show that you can even grind with the whole particle with the fat. And this is, you can compare both materials. You can touch, one we ground with the hammer mill, one with the pulverizer. And pulverizer will be just like a flour into it coming up in your hand. And it will be very, very, very nice, smooth, rather than have any granules into it. This is their headquarter facility. Any questions? This is his email, and he said make sure that you send an email to him in case they have any question. And again, I will email you also with the speaker and his presentation in case you have any question. And this was his brief presentation that so he was not able to come, and he, just because of surgery, and he asked me to just give an overview. Anybody have a question, please feel free to ask him.
Okay, so thank you, Roger, for the introduction. So good morning, everyone. My name is Albert. I'm from CPM. So today I will be talking a little bit about the production of high-quality fish feed with the next generation twin screw extruder. Okay, so for the starting, I will start with the fish feed outlook. Fish feed business itself is a big market actually. It's around $60 billion US dollar, according to the data in 2023, 2024. And you can see here that almost majority is happening in Asia Pacific. And with the good cost-wise or price, you will get around 10 to 13.5% profit. This is something that you can get from the feed business. The density of the pellets is really important. So that is why we always use the extrusion, especially if you're dealing with the floating one, because floating can only be achieved by using extrusion. This is some feeds that we have produced through our customers. There is some customers that is producing for the fresh waters. There is also for the seawater, like the groupers or tuna, that is also being farmed in Taiwan. We will start with the effect of the macro ingredients, because the quality of the feed itself, 40% is defined by these macro ingredients or formula, and then around 60% is defined by the process itself. The first formulation that I will be talking about is the carbohydrates. So you can see carbohydrates in here, especially there is only two, the starch and the cellulose. This both is made by the molecule of glucose. But in starch, you will have the alpha link. The cellulose, you will have the beta link. This link will determine their properties. The carbohydrates, as you can see, the starch, it comes from the tubers, from legumes, cereal grains, and mainly we use this starch is around 15 to 20% just for the binding capacities. And then the starch, other source, you can get sorghum, corn, and maybe some wheat. Generally, in our requirement, we always ask to separate the fibers, or if not, we want to be able to grind it very fine to be able to not block the extruder die holes. This is some example of the carbohydrates that we will be using. Nowadays, there is a lot of people in Asia is using the cassava. They can use up to around 20%, which is very high. And this becomes a problem because it gets really, really sticky inside the extruder itself. And then rice and corn is also some ingredients that is used mainly in extrusion. So this is the picture of the blockage that happens if you have this kind of fibers. Because fiber itself usually comes from the husk of the grains. Well, it was made from cellulose, hemicellulose, and also lignins, which mainly is not being able to use by the fish itself, especially if you're dealing with the marine fish or maybe some omnivores fish. They don't have the enzyme to digest this, so it's better for you to just take it out from the formula. The second one is the proteins. We're dealing with the animal proteins. We're also dealing with the plant proteins. The plant protein itself usually is this category. It has the tertiary and the quaternary structure, which is really hard to digest. So what we do is we need to cook it so that it will start to denaturalize and then open up the enzyme, the amino acids, and then it will be able to be to be digested by the fish itself. The main source is always the fish meal, but we also use a lot, like maybe the bone meal, we have some feather meal, and single cell protein. One fact about the feather meal itself is something that is really high in crude proteins, but it's not readily digestible. So you have to be really careful when you're dealing with this hydrolyzed feather meal. You have to really ask your supplier whether or not it's already being hydrolyzed or being enzyme digested or it's being fermented. If you have these 3 steps, then it will start to help with the digestibility of the feather meal itself. And then because the plant protein from soybeans, usually we will need to have a very good cooking. This is the example of the proteins that we are using. We have the fish meal, bone meal, and also wheat gluten. One thing about wheat gluten is it's not only giving the protein content, it also helps with the bindings. So this is something that mostly people in Asia will add when they're doing the pelleting and also the cooking of the extrusion itself. Okay, so this is different protein content for the fish feed. As we know, around 40 to 75% of the cost of the feed farming is come from the feed. So we need to really careful what kind of feed we are feeding to our fish itself. So we can see this is some species with the crude proteins that we are dealing with. The last one is the lipids. The main source is always the fish oil, but we are also using some soybean oil, also some corn oils. The lipid benefit is for the energy source, and also most of the time it's for the palatability and the attractants. If we're making the fish feed by extrusion, we need to be careful because we don't want to add too much fat, because if it's more than 7%, it will start to affect the durability of the pellet itself. Okay, so this is the starting for the process. As I said before, 60% of it is determined by the process. A good preconditioning is really important. The main target of preconditioner is to incorporate the steam and the raw materials. And then steam, when you're adding the steam, you will also add some moisture at the same time. This always happens. And then steam itself, it will improve the binding capacity and also it will cook the proteins. For us to be able to cook the materials, we need 3 things. We need the heat, we need the moisture, and also the time. The heat itself, it's really needed. We need to attain certain temperatures for us to be able to have a very good structure and also surface of the material itself. Later I will show you some photos that will show how it looks like. So how much steam do you need? You see these numbers. These numbers is what we call the specific calorie value. So if you're dealing with only protein, carbohydrate, fats, dry materials, it's all relatively low. But if you're dealing with some water, it means that you're adding some moisture, you will have a very high specific caloric value. This is because the heat itself is needed to break the hydrogen bonds between the molecules of the water. So at some times, there will be no increase in the temperature when you start heating. After some times, then the temperature will start to rise. Okay. So this is the approximate number. When we add some steam injection, around 1% of steam will add around 10 to 15 degrees Celsius of heat. And then the electrical power is 1 kilowatt is around 1.7 until 2.4. One thing that we need to pay attention to is the steam injection. If you want to attain a certain temperature, it means you're also adding the steam. So adding the steam, at the back, you will have to take it out again in the dryer. So you need to be really, really careful about this one. Steam quality is important. If you have a very good steam quality, 100% vapor, then you will have a very high moisture increase. This is because there is more heat transfer and then you will have attained the temperature very high. Okay, so this is what I mentioned. The temperature is important. If you have like 85 degrees, you can see there's still some holes in here. This is because the protein and the starch itself is still not blending together. And then when you get to 90, you can see that the holes is already getting less. It's because there is some interaction between the protein and the starch. When you get to 95, the protein and the starch itself will have like a complex bonding, so that you will have a smooth surface in the area. So this is really neat. You need to have this one if you want to have a good water stability in the water itself. Okay, so this is the twin extruder that we are trying to promote now. This is our, we call it the standard configuration that we're using now. So you can see here, because the cooking will start in the conditioner itself. So we want to have a better cooking before it starts in the extrusion. Because here, you will have around 3 minutes to around 5 minutes of cooking itself. While in the extruder, you will only have seconds. So you cannot do the cooking inside the extruder. Okay. This is some different types of preconditioner that we have. We have the single shaft, we have the thermal conditioner, double shaft, or differential diameter. Because of the time, I can only go for 2, so I will choose the thermal hydrator and the differential diameter conditioner. The thermal conditioner is being researched and actually developed because we have these problems in the existing preconditioner. The steam is injected but not absorbed, and then around 15 to 20% is being left out, and then it goes out from the conditioner. So what we do is that we close up the inlet and the outlets. We're using a screw paddle so that the steam will not go out from this place. So, and then add it with the high rotation and small paddles, it will start to have a very good mixing inside. And also, as what Dr. Riaz already mentioned, we're also using the same method. Liquid and the steam is added at the same time, and we're using the pressure of the steam itself. And then the DDC here, it works to give some time for the cooking, because the DDC itself can have this kind of movement. So the small shaft will push it backwards. The big shaft will try to push it forward, so that you will have this repetition, and then you will have a better retention time inside the cooking. This is some benefits. The biggest benefit that I can say here is the drive system, and also we have the food grade design. Everything's rounded so that you will not have any accumulation of the dust. Okay. So we offer you 4 benefits. The first benefit is reliability. We use the gearbox that can have a high torque gearbox with the rotation up to 600 RPMs. Okay. And then also it have efficient cooling and heat exchange systems. The second one, you have the protection. We have a torque limiter to protect the motors and also the screw at the same time. The third one is the flexibility. We have a very long screw with a lot of configuration that you can play with whenever you have a different kind of formulation in the future. And then the last but not least is sustainable. We want to be sustainable. We're using this kind of permanent magnet motors so that you will have energy saving in that. If you're interested about this one, you can come to our booth tomorrow, and then I can explain to you tomorrow. We're also using a venturi design. So venturi design, actually, the main purpose is to increase the pressure in the last barrel, and at the same time, it will be able to uniformly separate the pressure to the outlets. So this is something that we will be using. Okay. And then some die qualities, of course, depending on the supplier that you're using, they have the full open segmented holes with inserts. The main thing about the die plate is that we want to be able to have the good restriction so that it will have the good pressure and then the best temperature that you will need for the feed production itself. And on this side, you can see this one. This is something that we want. This means that the pressure in the hole is uniform enough. If not, then the pressure will be somewhat like this, and you will end up with some materials that is not uniform in the size itself. Okay. And then extrusion die open area. If you have a fewer die holes, it means that there is a large restriction. The material will have a high velocity inside the holes itself, and then what will happen is the SME will start to increase, and then you will have higher pressure. This is something that you will need to consider if you want to produce your feed. If you're producing a sinking feed and you have a very aggressive profile of the screw, it will not be able to happen because some of the feed will start to float. So this is something that you will need to change. The water and the steam automatic system is really needed if you want to have a consistency, because we will be adding a lot of PRV, a lot of valves, a lot of flow meter for it to be able to precisely add the steam and the water itself. Automation system is based on the formula, and then usually nowadays we're using the one-touch startup. So everything can be done by your operator through the control room. This is the parameters of the feed production. The most prominent difference is on the extrusion temperature, the barrel itself, and also the die configuration. So for floating feed, we always use a small LD because we want to keep the pressure from inside the barrel and then get it out as soon as possible from the pellet die holes. Okay. And then this is the effect of the different moistures. So this is based on a research that you can see if we add more moisture on here, you will start to have lower motor amperage, you will have less pressure, you will have less temperature, and then you will have more mass flow. This is because the water itself will have some lubrication effect so that it will just go out. But does it mean that it's good if we add too much water? Actually, no. This is what will happen if you add too much water. From 220 up until 320, you can see that there is an enlargement in the expansion. But when you get to 350 and 370, actually this expansion is not that big. So what happens actually is this one. When you add water, it will cause some expansion. It means that the density will start to go down. But when you add too much water, it will have some collapse in the moisture itself, because there is not much integrity of the material that you can keep. And then you will have some collapsing in the bubbles, and then you will increase the density again. Okay, this is some DCU, something that we also use nowadays for making the slow sinking feed. The main purpose is we want to control the water boiling point. We want to lower out the flash point so that it will not expand as much. So it will look somewhat like this. If you're doing it without the density control, the material will just go out, and then here there will be a lot of expansion, and then with the compressed chamber, you will have less expansion. This is something that we want to do nowadays. Okay. And then this is something out of the topic, but I need to convey. We need to have less mechanical conveying. So when you're using bucket elevator, you're using a lot of chain conveyor. What will happen is that it will add some broken pellets. So based on this research, from the first cycle until the 8th cycle, you will add from 17.5% until 50.2%. So the more times you do the bucket elevator, the chain conveyor, you will have more broken pellets. And at the same time, you will add the generation of the dust itself. So this is the benefits of the pneumatic conveying itself. We want to reduce the moisture before entering the dryer. we can also help to separate the sticky lumps during this conveying. So automated feed plant. This is actually the AI nowadays is trying to enter in our business. It's not for the, it will not like replace the humans, but it will help to increase the collaboration and the efficiency itself. Okay. So this is some benefits of the automated plants. Of course, the efficiency will rise. Okay. And then some consistency because you will have the sensors, and then cost reductions, and also safety. So what can be automated? Actually, every part of it can be automated. So because of the lacking of time, I cannot go one by one, but I have all the sensors, or maybe if you want to have a very practical way of doing this, I have it. Maybe tomorrow you can come to our booth. Okay. And then the main thing is that we want to have it for predictive maintenance. You can have this kind of sensors to help to predict what kind of damage will happen to your. Okay, and then the last but not least is sustainability in your factory itself. This is something that we encourage you to do. Do some local resourcing, do some waste valorization, maybe use some renewable energy. This is something that we can do together. Okay, thank you for your attention.
Is there any question for Albert? Very quick questions.
Good morning, my name is Michel Pereira, and I came here to discuss with you a topic about float or sink. Where should I point? Yes. My biography, here's some words about my company, but here we'll talk about the technology. So, a brief introduction. We have several speakers this morning talking about similar topics and similar hardware to produce both sinking and floating fish feed. So I tried to implement my presentation with some practical cases that I hope can help you. So my introduction is about the technique itself and the hardware, and then in chapter 2, the buoyancy, I'm gonna discuss when your floating feed sinks and when your sinking feed floats. So maybe it can help you with your production. And then finally a takeaway message. So what we need to understand when we do extruded fish feed is that it's a kind of a complex process that connects all the parts in the plant. For example, we need to relate the feed formulation, the process variables, the quality of the raw materials, and also the technology. We cannot play without having all them considered together in a holistic view. Mainly, if you're producing a wide range of aqua feeds, because if you only produce a floating fish feed, it's not so complex. You every day producing the same, but if in the same line you produce a floating and sinking, it can be complex for the operator, so you need to support them. And also for sure, when we do high energy feeds like a salmon or trout, this can become quite complex. So let's dig in it. How we see the extrusion in a very simple way. I learned it from my colleague from the US, like a popcorning. So we're gonna heat the corn. The shelf itself cannot be broken because it's very strong at the beginning. So inside, the water will heat up. It will pass the boiling point, but because of the skin can hold, the kernel remains. So the pressure builds up until a moment it's gonna break up. And then we have the expansion of the popcorn. So in a parallel is what happens inside the extruder. We are creating the pressure until the die plate, which is the restriction. And when the product or the dough passes through the die plate and faces atmospheric pressure, or maybe we have a pressure chamber in the front, then we can see either high expansion or low expansion, depending on the type of a feed that we are producing. So a phase change will occur inside the extruder. We can see here these are transport elements. We start to compact the product. Here we have a transition, and then we have a fluid. So if we open the screw, that's what we can see. This was in the solid state. Here this transition, and here is where we really had the melt of the product. And basically these are the three main variables: is time, temperature, and moisture. And pressure is a consequence of the restriction we have here in the point. So basically the same model that we see this morning again. We have the water high compressed here. When passes through the die open, it will face the atmospheric pressure, and there will be a change in the phase of the water from liquid to vapor, and that's what will create these pores, these little bubbles here inside our product that will generate expansion. If we are producing floating fish feed, we want a high expansion, but if we want sinking fish feed, we need to control the expansion. The expansion is related with the viscosity of the melt. So there's a little mistake here. It's opposite. So high viscosity will give high expansion. Low viscosity will give a lower expansion. In a way, we can change the viscosity of the melt. It's, for example, adding water into the barrel of the extruder. We can control the expansion. The thing with the water is you need to remove the water later in the dryer. So basically we spend more energy. That was in the beginning how it was done, but now we have a better techniques. You also could put some oil. It will work in the same way, but it may change the recipe. So for example, for sea bass, this type of feed fish, it's okay to put 1 to 3% of oil into the barrel of the extruder to avoid expansion, because in the end, the total oil content of this type of feed may be 18% to 20%. But if you're going for salmon feed, where we can have a 40% oil, we will need a certain level of expansion, and therefore we cannot do this. The vapor pressure is what will drive the expansion, and is a function of the temperature. So we can see here, usually we're gonna be working in this range here, because this should be the temperature of the melt leaving the extruder, more or less 120, and this will be the resulting pressure of the vapor of the melt. How we can expand the feed? As I told you, the floating fish feed is not so complex, because we can play with this restriction here. So if we put a smaller ring here, we create more restriction and therefore more expansion. It can be done manually, which is not so practical, because we need to stop your extruder and change the setup here, so it takes some while. But there are also solutions with, for example, a back pressure valve, which will automatically change the opening area of the restriction here. And it's more practical because you can do this just online. So if you work in your line with several types of feed, the back pressure valve can be helpful, because it will help you when you have a feed with a higher or lower starch content. When you have a lower starch content, you use more restriction. If you want to do the sinking fish feed, the tail here is not to expand. So I told you one of the techniques is to use water in the barrel. The negative is then you need more energy in the dryer, and also the water stability will not be so long, because it didn't cook so nicely the starch. So one of the options is we can use a density control system here in the barrel. I must admit to you, this is a kind of too much for sinking for fish feed. Usually this is used in other industries, like human food, if you want to prepare pasta or this kind of things. But I have seen this being used in aqua feeds. It's just very complex to operate with a vacuum. I have seen this port also without anything over there, just open. The thing is, you need to change the screw configuration here. So if in the same line you're producing different types of, several types of fish feed, and you need to change the screw configuration, it will take too much time with the machine stopped, and maybe not so practical. A second option would be to use a pressure chamber here, as shown in the presentation before, and this can be really nice because you can put 1 or 2 bar above atmospheric pressure over there, which will avoid the expansion of the feed. So you have a good cooking inside the barrel, and then here you can control the exiting pellet density. You can see here the difference when we are using it. You can see this is much more expanded. See how rough is the finishment, and this here is when we are using the pressure chamber. So okay, that was the introduction. Now I bring you 3 cases, and maybe you can recognize some of them within your production. First one is I'm producing floating fish feed. I collect a sample after the extruder, which is very usual. The operator is always collecting samples and throwing into a bucket of water, and all the product floats, but the finished product, after drying and coating, some of the product sinks. We're going to evaluate what could be happening. A second case, if you are producing sinking fish feed, you collect the sample and all the sample sinks, very good. After drying coating, the product still sinks, but look, when the product reaches your customer, some of the product floats, and that can be not so good for the quality of your product. Your customer is going to complain. What is happening in this situation? A third situation is if you're producing sinking fish feed and you collect a sample after the extruder or sometimes after the dryer, and a fraction of the product floats. So let's evaluate what could be happening. We have seen this table before, so we have some references of what should be the bulk density for each type of feed. Consider the behavior we are expecting. For example, fast sinking should have a high density, something higher than 640 grams per liter when we put on salted water, so some references we can have. And if we are playing with floating, which usually is in fresh water, should be less than 440. In Brazil, at least, we do 420 maximum. So we have here some references about how we should design the die plate. These are just a reference, rule of thumbs, because it also depends the geometry of the hole, but you can use this as a reference. Also regarding the starch content, reminding that it would be too easy if we could use a lot of starch in the formulation, because the starch will always help to float, but the fish itself cannot digest the starch. So the starch is used there as a glue for the product to have a good mechanical structure, but we should use it as minimal as possible. And also, if you use, as I said before, oil, you can also control a little bit the bulk density, so more oil, more heavy will be the product. So when we are drying, it's expected that somehow we can try to do it as gentle as possible, but some kind of a difference will happen, because we will have a gradient of a moisture. We will have a little bit of moisture inside, then outside, which with the time is gonna have an equilibrium, but it's expected to have something inside of each of the pellets. If you do the drying process in a very aggressive way, then it's much worse. So let's see if we do it correct. We'll have a smaller gradient and low stressor on the pellets, and also this equilibrium will be reached in about 1 day. So this center that is a little bit higher the moisture will spread the moisture, and after 1 day you will have the pellet with equilibrium. But if you do the drying process too aggressive, first you have a larger gradient, and also you can have a significant shrinkage, and that will come to the first problem. We have a very aggressive drying case. We created what we call case hardening, so we basically block the shell of the pellet so water cannot go out inside. We also have a shrinkage of the pellet, so this will result in a higher density pellet. This is why your tilapia feed sometimes will sink after the dryer. This is very common. I just got a call 2 weeks ago from my main customer in Brazil telling me there was something strange with his feed. He could not understand, but that's what was causing, because he were using too high temperatures and too higher air volume in the first zones of his dryer. Needs to do a more gentle drying. So that was the situation 1. If you have a sinking fish feed and somehow you also create the case hardening pellet, within some days, this moisture inside will tend to equilibrate and it will soften this hard case, the skin here, and it will allow the pellet to swell. So in the end, the pellet will be bigger than the original one, and this will decrease the bulk density, and then your sinking fish feed, some of them may float. So this would be the situation number 2. The situation number 3 now. It's expected to have some variance in the size of the pellets. We can see here, even this pellet is really nice. Some are smaller, some are bigger. You see, this is the bigger one. So this is the model. We have a bigger, oversized, and we have some which are smaller. This is real data that I measured once. This is floating fish feed, so it's the worst case. For average pellets 4.1, I measured hundreds of pellets. I got a standard deviation of plus minus 0.3, so it's more or less 7%. And also the length, there was a variation of more or less 7.7%. It gets worse as the knife, for example, wears out during a long run. Then for sure you will have a higher here, and also the die plates can wear a little bit, and then you will have a little bit bigger in the diameter. So how do we calculate the bulk density? It's very simple. We have a sample, we have a volume here, the sample, we measure the weight, and then we can just do the weight divided by the vessel volume. We can calculate the bulk density. This is normal. This is not so common to be done. This is the pellet density. So then we need to know how many pellets we have in our sample, and then we divided by the number of pellets, the weight of the sample. We have the pellet weight, and then we're going to calculate the pellet volume. How we do that? We have a formula here. It's basically the volume of a cylinder, and then we can calculate the density of the pellet. The Stokes law describes the behavior of a particle in a fluid. We can have an idea about the velocity. Now we are talking about water and about pellets. So what matters for us is the difference in the density between the pellet and the fluid. In this case, we are talking about water, and also the fluid viscosity, in this case also water. And we can have an idea how fast will the pellet sink. If we know the velocity, we also can know the time. Very good. But there is one thing else, which is the water tension. Okay, so it can avoid your pellet to sink. So they created something called the Jesus number, which has this formula here, but it has some empirical data. The Jesus number is the inverse of the Bond number, so maybe this is easier for you to calculate. We are just using the tension, the surface tension of the water, the difference in the density, the gravity, and the length of the pellet, the perimeter, the wetted perimeter. So I made a simulation here for a difference of only 50 grams per liter. And you can see in this case, even pellets with 5 millimeters up to 6 millimeters could float. It's common to see when people are working with smaller pellets, 1, 2 millimeters, they will throw it against the water, because if you put it in gently, they may float. This is very common when you're playing with shrimp feed. So what about the pellet density variation? So okay, we have the cylinder, this is our model. If we have a variation in the radius, this is how it becomes. If we have a variation in the length, this is what it becomes. So how do we apply this in the practical life? Let's make an example here. I took a sample with this weight, and I counted how much pellet it is. This was the volume of my vessel. So I can calculate very easily here, bulk density, in this case, 660. Should sink. We saw in the tables before. Now we're going to calculate the pellet density. How we do? We get the sample weight divided by the number of pellets, so we know the average weight of each pellet. Then we calculate the volume of each pellet, and then here I have the pellet density, 1072. So if we look to the water, the salted water has a density 1030. Fresh water has a density 1000. So in this case, this pellet would sink in both salt and fresh water, because its pellet density is bigger than these two, okay? Either salted or fresh. But now we have some variation because the process is not perfect. This variation may occur still in the extrusion process or during the drying. Not all the product will shrink in the same way. So let's imagine we have a variation 3% in the pellet diameter. Now our diameter is not 8 anymore, it's 8.2 with 3%. And now I calculate a new pellet density of 1,011. This should still sink in the fresh water, but float in the salted water because now we have a smaller density than the density of the salted water. If I have a variation of 6% in the pellet length, which is usual as the knife gets wear out, then now we have a little bit larger pellet length, and then when we calculate, we have a similar average pellet density. So what's the conclusion? These pellets will float in salted water and sink in fresh. And if these two variations apply at the same time, then the resulting pellet density is even worse, is lighter, and would float in the two cases. This is how we explain the situation 3. So that's the end of my presentation. I have here some takeaway message. So it's very important across organization contamination. We see the quality controlling the quality of the feed leaving the factory, but sometimes without the control of the quality of the raw materials, for example. The price of raw materials may change, and then the purchaser will try some new supplies, and that may change the quality of your feed. It's very important to be aware of that. Second, a proper formulation that may be adjusted to circumstances, and the dye design is really important for each type of feed. Last but not least, also a gentle, steady drying process, because the drying process can affect the quality of the feed. That was my message for you, and I thank you very much.
My name is Terence Hovels. So I have been with Andritz for just short of 2 years now. Prior to Andritz, I worked for a large pet food manufacturing company in the UK, where we had 4 extrusion lines. We produced in excess of 160,000 tonnes a year of pet food. But obviously, I've got more than 8 years' experience in the feed industry. I am 38 years old. A little bit more about myself. So I'm actually a passionate carp angler. So I do understand the need for good quality aqua feed pellets, and I've seen firsthand the effects of what Michelle and Dr. Rose, everyone has spoken about this morning. So there is a huge importance in the process. So a little bit about my background. So I am actually a mechanical engineer by trade. So I started as just a normal engineer, just a shift engineer, and I was then promoted up to be a maintenance improvement manager. So I do understand the importance of the maintenance aspect of the whole process, from grinding, conditioning, extruding, coating, etc. So there is a lot of the process that deserves a lot of respect. Each stage is as important, if not as the next as well. So this is what we're going to talk about in this presentation. So obviously, influence on aqua feed, floating and sinking. We're going to a little bit on extrusion, pelleting, the process, and then there's going to be some final remarks. So here at Andritz, we're feeding and fueling the planet. Here's just a little bit on the global locations of where we are. So we've got service. Obviously, we've got service in North America, South America. We've got a lot in Europe here, and we've got some in Australia as well. Obviously, we've got manufacturing aspects. We've got in Slovakia, and we've got in Foshan. And then, as well as service and manufacturing, obviously we've got in the USA, and then obviously we've got Geldrop in the Netherlands. So, expertise and competencies. So this is what we can offer. So we can offer single equipment. So we've got 186 years experience in single equipment. We've got process and application knowledge. Then we've got engineering. We've got project management. We've got automation, and then we've got services. So we can offer anything from single equipment all the way up to plant operations. So we have a big focus on becoming a strategic business partner. We provide complete plant solutions for feed, pet food and biomass industries. geo-exec specifications at the lowest possible total cost of ownership by leveraging our extensive processing expertise and experience. And with the industry's most trusted services, we are always there for you. So influences on aqua and feed. So here's a very simplified overview. You know, we spoke a little bit this morning on grinding, particle size, how that can affect it. So particle size can affect retention time, absorption, diffusion, you know, how we want to start that cooking, the conditioning process. Also the effect of that it can have on other machinery. You know, if we grind at a larger particle size, you know, we are going to experience signs of accelerated wear in the extruder, especially on the screws. So a smaller particle size has less wear on certain parts. Conditioning, obviously the influence in temperatures, pressures, fill levels, retention, very crucial on getting that first part of the process right. You know, we want to start that cook. We want to start the cook. We want to get the correct retention. We need to start the gelatinisation. We want to get that there. Process parameters, temperatures, pressures. You know, we spoke this morning on how these all affect everything. So if we've got the incorrect temperatures in certain parts of the extruder where we want to target some expansion, you know, we need to be very careful there. Same with pressures. If we're not hitting the correct pressures at the die head, we're not going to get the correct expansion levels at the extruder. We're not going to get the correct densities that we're trying to achieve. Die design. Michelle just touched on that a little bit. Obviously, die design is a very important factor when we're looking at open area and what we want to be looking, floating, sinking. Obviously, there's a huge factor in die design which gets overlooked is die design and how little wear can affect such a massive performance factor in the process. Drying and cooling, obviously, we need to look at how we're going to bring this product to a temperature where we can store it, can pack it and send it to a customer. We've got the extrusion. You know, we're going to take this meal from a certain viscosity and then we're going to turn it into a pellet. So we need to be very respectful of how we do this as well, and as well as formula. This is probably one of the most important as well. You know, when we look at proteins, carbohydrates, fats, lipids, all of them, when you look at them all on paper, yeah, they all look great, they all look like they're going to do the job, but when you actually put them all together, how do they all react? Because certain carbohydrates, proteins, fats, etc., just because on paper that they all look good, it doesn't mean that they will all react, cook at the same behaviour. So we've got to pay massive attention to that as well. So in the real world, obviously, it is a lot more complex. So if we're going to understand the performance, if we look at this flow and it shows how various things depend. So if we look at grinding size, how it affects product quality, then obviously it's going to affect the extruder output. But obviously it's going to extruder wear and tear. So as I said earlier, a smaller particle size, you're going to have a very good appearance. It's going to look great. There's going to be less wear. It's going to be great to condition. Larger particle size, take a little bit more time for the diffusion. You get the water back in, but then obviously it's going to have a bit of an effect on the extrusion on the screws as well. So there's an element of wear. Dry recipe, dry feed rate, then obviously extruder output, and then product temperature. Then if we're looking at water, if we're going to put it in, it's going to affect how it's going to cook. It's also going to affect the wear and tear on the extruder. Steam addition, but yeah, I think you can see how all of these separate factors all influence another chain reaction in the process. So everything deserves an element of respect, and it's not just a case of just running. You know, it does require respect, and this is where I think the AI is going to start taking over now, because all of these here, if we can eliminate the human error factor of elements in the process and we can start to automate it, this is where the consistency comes, and this is where we're going to hit our quality goals. So typical fish species and their feeding behaviours. Obviously we've got trout, Obviously, it's surface feeders and mid-water. We've got tilapia, sea bass, sea bream, mid-water, and then bottom feeders, carp, shrimp, and catfish. Obviously, you know, we've spoke about all these this morning. But yeah, and this is where we're going to start looking at what sort of densities and how we're going to start feeding these species. So, formulation, sink V's float. You know, this is something that often does get overlooked. And obviously, when we look at basic nutritional composition, it remains similar between the two. So obviously, we look at proteins, whether it be animal or plant-based. We've got fish meal, feather meal, poultry meal, shrimp head meal, soybean, corn gluten meal, and wheat gluten. Obviously, why are these important? Well, we need these for we need them for growth and tissue formation. We've got the essential amino acids and energy and reproduction. When we look at the lipids, the fish oil, the poultry fats, etc., you know, this is where we're going to get the energy sources, the essential fatty for the growth aspect and for the soluble vitamins. We'll touch a little bit on carbohydrates. So we've got the wheat flour, the rice bran, the maize, the meal, potato starch. Obviously, these are all good binders for pellets, and they're a cheap energy source. And this is where I was talking earlier. Obviously, when we start talking about formulation, raw materials, yes, we can't just talk about starch and binders. You know, all of these react, they have different absorption rates for moisture, so it's very crucial that we don't overlook and just, you know, focus on cost. You know, there is an element of that. The recipe has a function in it, has a task to do. We talk a little bit on vitamins. Obviously, there's vitamin A, D3, E, K, folic acids. Obviously, vitamins are essential for growth and metabolism support, immune system boost, and disease prevention. Obviously, this is quite a big factor at the moment in the aqua feed, because we know the challenges we are up against there. And then at the bottom, we've got some amino acids, obviously growth, immune function support, and reproduction. So we look at starch. So obviously we've got cereals. So we've got rice, 10% protein, obviously has a 75% dry basis starch. We look at maize, 71%. Then we look at wheat, where we're coming down to 66. Peas, wheat gluten, and then soy meal, obviously. So when we're looking at the starch dry basis matter, and obviously we're looking at where we want to get it from, we just need to be very mindful of how these raw materials work. Obviously, starch is a major source of energy. In fish feed diet, starch content is normally low, 5 to 10%, because most fish species are carnivores. Starch only acts as a binder. During preconditioning and extrusion, the starch granules lose their organised structure, gelatinization and melting point. So obviously, in the pet food industry, it's brilliant. We're working with very high starch levels. So binding, we get a good structure to the kibble. But obviously, when we come to the aqua feed and we're using low starch levels of 5 to 10%, this is where we need to be absolutely at the top of our game with our process, because such low starch levels can affect the pellet durability and the hardness, and then actually getting the structure of the pellet. It's okay making a pellet. You know, we're going to hit a capacity, we're going to hit a density, but the pellet still needs to have a certain hardness and a durability because of how the fish farmers may transport this pellet, you know, via conveying or blowing, you know. So it's not just a case of hitting certain quality parameters. Everything has to be there. You know, it's got to be able to be transported as well. Formulation, sink V float. We've just spoken about this, obviously, and how the Jesus number is such a crucial thing. But obviously, starch plays a key role in buoyancy of aqua feed. Floating feed needs a higher level of starch when compared to sinking due to the need of increased expansion and decreased weight. For example, floating, 15 to 20% starch content. Slow sinking, 12 to 17% starch content. And then obviously, sinking, we're getting right down there now, 7 to 12%. So, challenges in formulation. So what we see now, there's a drop in marine protein use and an increase in plant-based substitutes due to sustainability and cost. These ingredients vary in protein solubility and water absorption. So these are some of the challenges we're up against at the moment. Functional binders variability. So binders such as wheat gluten, guar gum, fish gelatin can all vary in hydration rates leading to sticky mash or weaker pellets. I think you're going to have to take over now. We just need... So obviously, my talk is quite a unique one, so we're going to have to do a split. So if you can just take over from the challenges, please.
Any so far question that he was talking here? Any question there or any issues there? Okay. As he's talking about formulation, and basically you have to have different kind of ingredients, functional binders, we talk about it, and of course high level of fat, you have to use that for the vacuum coating system, and then of course you have some kind of fine grinding also you need there as well, and also the sinking feed required starch. If there's a lower starch, because minimum requirement of a sinking feed is 10% starch. But if you go more than 10%, then you have a challenge also. Therefore, the feed formulation is very important. It's a challenge that if you are not proper your starch level, your fat level, your protein levels, you will have an issue with that floating and sinkability. Therefore, we want to be very careful with that as well. And now we're going to talk about again the same thing what previous speaker was talking about also there. That was floating and sinking. How you can do that one here in this case. Again, this is a table you've seen several times. That's the requirement that you need it, how much density you need it to make it float or sink. And again, this will be also from the fresh water and the sinking water. And sometimes what happens is that it is become a challenge because your density is very close. Like let's say you need it more than the 600, therefore you are on the very neck, very close to that, and that's why sometime after it start floating and sinking, you want to make sure you give enough cushion to that density. You not want to be exactly close to that, otherwise you may have a trouble. Therefore, basically you can see here, the fast sinking you need to have more than 640. And similarly for freshwater is less around 600. Therefore, you want to make sure that you are close to these ranges. Sometimes these ranges are very tight, and that's when the issue comes in later on, and that's what happened there. And what are the factors will affect the density? We have so many different factors here. We talk about the first table, he showed that if you change one ingredient, one things, it will change everything. For example, the screw speed, if you change that one, your steam addition, water addition, oil addition, feed rate, temperature, all these are the factors that he was showing on the first table. And if you change one, it can change everything. You don't realize that because it has multiple changes there take place there. And you will see also here, we talked about earlier about that die design there, the die venting head. You can put there's a vent there, you can put that one, and the vent will usually, because what happens, it will make a sinking feed. Sometimes you can put the vent and then put even vacuum on it, make sure that you're pulling all the vacuum on that as well. Therefore, there's a lot of different techniques can go there in order to make floating and sinking. And then, of course, your configuration is one of the most important one. The screw configuration is that what kind of configuration you have it. Is the high shear or the low shear, or is it what kind of configuration you have it. You can use a cut flight, you can use it shear locks in between. You do a lot of different things there, and you can work with that one. And of course, your formulation. Therefore, all these factors will affect that when you are processing there. And therefore, these are, if you change one of these parameters, then it will change everything. And that's why he was saying that AI can help, because we can put all these parameters there, and we can put it up there, and then it will help you. You want to speak now? Okay. Therefore, basically, these are some of the things that we want to pay attention there, because we don't realize that one of the operator goes there, change the screw speed, and we're running at 400 RPM, they reduce it 350 RPM, everything will change. You guys are running at, water addition in the morning, operator have a water addition. When the other person comes afternoon, he see that, he can just change a bit more water, that change everything. The water is not going to change only one thing, it's going to change multiple things there. Therefore, there's a lot of things happen there as well. Therefore, I'm going to continue with that water stability. And water stability basically will come from there again on your formulation. How will you do that? Of course, it has to be, the reason is that it's important that we have to reduce all the waste there. And also, if you have to have most of the times, we don't use any binders in the aquatic feed when you use extruders. It should be 24-hour stability. Sometimes we see it, even people will make it feed there and keep it for that. But if you are making it not proper, it may be disintegrate in the water. You have a lot of waste there, all that. Therefore, shrimp feed should not be disintegrated in the water for minimum 2 hours because they are slow eaters. They sense slowly, and then at least take them shrimp to 2 hours before they can start eating their feed. And if your stability is not there within 2 hours, it will disintegrate in the water. Therefore, you have to have quite a few different things there that we have to pay attention to that for the water stability. And again, this is basically depending upon, again, your throughput, how much throughput you can get. You can see here the sinking type, how much open area you need per square ton. Therefore, you have to calculate accordingly. That's one of the most common mistakes. Everybody does it. They buy the state-of-the-art extruders. When they go there, it comes to the $1 million. But it comes to the die, they start drilling their own hole. Doesn't work that way. You can't drill their own hole because you have to calculate the proper throughput. Here is the guidelines for the sinking, your open area, and then of course floating your open area, how much you need it, because if you are not properly design your open area, you will be having an issue there. Yes, you can increase the production and you can decrease it, but it will not float or sink. Therefore, you have to keep it also expansion ratio, how much is going to expand in the floating and how much is going to expand also in the sinking. In the sinking also we have some expansion take place. Therefore, you calculate all these things before you make your die design. And sometimes it's like whole thing is focused on the die design, and there's a whole chapters and chapters written, and there's an engineer who calculate that whole throughput. You have to have it, make sure whatever the angles are, it's 45 angles, and L over D. That's other things go to the die design, and then what kind of, either using an insert or using a die hole. All parameters are count toward the die design. It's not that simple that you can drilling the hole yourself and then making a machine, because that never worked there. Okay, also, as that 100% right now, the floating feed made with that extruders. The sinking feed still have some kind of people are using it with that, is using a pellet mill. And pellet mill was the common method. Everybody used the pellet mill. And of course, it has some advantages as well in the pellet mill too. And therefore, here's the enders that have, of course, you can have a pellet mill, you can have it also extruders. And why people are moving into the extrusion system rather than the pellet system. Yes, there are quite a few different things, and here's a very good comparison. If you can see there, in that extrusion we need a very good grind, whereas in the pellet mills we can also compromise a little bit. Of course, oversized particle, sinking behavior. With the pellet mill we can only make a sinking feed. We cannot make a floating feed there with that pellet mill also. Therefore, it will be with this here we can also have floating feed, and so of course slow sinking feed, fast sinking feed. And then in the pellet mill you have to have post conditioning. That means once you make the pellet, then you have to have other conditioning so we can cook the pellet, because it does not properly cook in that preconditioner there. And then of course, water stability in the extruders is very low, as mentioned, at 24 hours without the binders. And in other case, we have to use the binder sometimes in the pellet mill, and that's what it is extra cost there. And then drying, of course, in the extruders, we are cooking it with the water. Therefore, we have to dry later on, whereas in that pellet mill, sometimes we don't need drying, we just need the cooling there. And formulation wise, in the extruder, we can use a least cost formulation. You have a variety of different ingredients into it. Whereas we are very restricted with the pellet mills because you have limited starch, fat level, how much you can use it. Whereas in that extrusion system, we have much more flexibility that we can use there, all that. And of course, you can use a low cost ingredient in the extruder, not low quality, low cost ingredients in the extruder, whereas in the pellet mill is limited that you cannot use that as well. And of course, there's much better feed conversion ratios when you use it in the extrusion as compared to the pelleting. Digestibility is very good. Pellet length is, of course, that's easy to control. And of course, starter feed, you can make it 0.3 millimeter to all the way to go to 60 millimeter. There's a twin screw extruder making 0.4 millimeter, 0.6 millimeter, 0.7 millimeter. With that pellet mill, you're limited with the size. You can't go that small, and therefore there's a different application for that. Therefore, there are quite a few different advantages that we have it, and then we talk about some other benefit with that you can use with the extruder there as well. And this is basically just extrusion is the focus. We're going to focus on that because, as I said, there's still a lot of places they use the pellet mill to make a shrimp feed and other feed. But then after that, I have seen some of the plant where they have a 20-meter long preconditioning system. Once you make that, then you go to have a conditioning there all the way. You have to condition the pellet, and then of course digestibility and quality is not there as well as much as you want. And again, we saw the process. And funny thing is that extruder is just one part of the whole system making aquatic feed. We don't pay attention from the first receiving all the way to the drying. Because if your grinders are not working properly, you can't make good extruders. If your coating system has some issues that you cannot focus on that. Look at the whole system. Don't just look on the extruder, because extruder is the heart of the whole system. Yes, we are cooking with the extruder, but what if our grinder is not right? What if our coating system is not right? What if our conveying system is not right? What if our some of the drying system is not right? That quality will go bad. Therefore, it's not only just the extruder, it is the whole system we need to look into that. How you're getting the receiving the raw material, processing it, grinding it, cooking it, all that. Therefore, every single thing will participate, every single thing will contribute toward your quality of the pellet. And again, you saw earlier, this is the typical system, you see it. We have some kind of feeding device, a live bin, of course, which you get your recipe. For a live bin, you have some kind of screws, materials comes into that, your screw feeders, then you have conditioning system, then you have extruders. That's the thing we saw earlier this morning with the several speakers. This is the pre-conditioning system, this is your live bin, and this is just, of course, screw feeders, and that extruder comes in there. Yes, go ahead.
So one thing that I have noticed, obviously, at my time in Andritz, you know, we want to bring this process to a more consistent and, you know, easier for operators, because we do appreciate the challenges that they are up against. And I think one thing that we need to look at is obviously how we do our batching systems. So there's the volumetric and there's gravimetric. Now, in my experience, obviously, the loss in weight system here brings the accuracy of plus or minus 1%. But when you use the volumetric, obviously the accuracy is not there in your system. So, you know, you can be in excess of plus or minus 10% accuracy. And when we start looking at, obviously, oil addition, steam, water, you know, all of this starts to add up. And it just presents so many challenges for the operators in here. You know, if they're on the... if we've got the loss in weight system, we've got all the flow meters, you know, everything's working great, you've got the accuracy there, you can bring your consistency in. But when you're on the volumetric, and you obviously, we're going to input a density of 560 of the raw material, you know, that's that one batch that you've taken a sample of, you know, and we know from experience that densities change from batch to batch. And if you can't control this, you've got no way of keeping this whole process stable. So that is just one comment I just wanted to make up on the extrusion and on the setup itself. Obviously, we've talked about temperatures and pressures, etc. So obviously, we're going to get the meal in. We want to start adding the water. We want to get the water into the raw material, and then we can obviously start the cooking process where we bring the steam in. We spoke this morning on, obviously, times and temperatures, you know, from 90 seconds to 240 seconds, in excess of up to 90 degrees, 95 degrees. So this is some ideal process parameters. So 90 to 240 seconds in the conditioning process, with temperatures up to 95 degrees. So this is just going to help you bring your pre-conditioning up to its optimal and help you and the operators achieve a good quality product going into the extruder itself. So, unique steam liquid injection system. You know, we saw in the presentation earlier from CPM, you know, we are all using the same method. The same method works. It's the correct method, and it's proven. So we will bring the water in. Here, the same point as the steam, we'll let the steam do the work. It will naturally pull it in because we're putting steam in under pressure, and it will bring up the temperature as well. We've got different types of conditioners, so we've got the single, we've got the DDC, the dual setup, sorry, the smaller one on top of the other, and then we've got the twin shaft there as well. So, typical recommendations for degree of filling, 40 to 45% in the conditioner. More than 40 to 45%, you see a negative effect on the mixing efficiency. So this is just how we set up our conditioners and the paddle configuration and how we want to run them to bring up optimal running process. So flexibility and control. So we've got extrusion, single V twin. So efficient extrusion, produce pellets as small as 0.6 millimeters. Extruders can handle high temperature and moisture content from the conditioner. We've got die plate needs to be sized accordingly to bulk density capacity, etc. And then obviously we have a VFD drive in the main motor. So having a VFD drive gives you a lot more flexibility in the extrusion process. We can slow it up, speed it down, and this can help the operator can control density, start, expansion, etc. by changing the speed in here. And but changing the speed in here, all we're doing is affecting the tip speed and the temperature. So here we are in the extrusion. We have a system called the FlexTex. So what we can do is we can increase the SME to produce formulas with low starch. So what we can do here, we can control the position of the piston. So this is in the venturi, so we can open and close this aperture here, and what it will do, it has a direct effect here. So if you see the video, if we start to close it, we can increase the fill level, which gives us a much better cook. And then when we open it, the fill level is reduced as well. Obviously, we have the FlexTex, but we can combine it with the expansion control system. So here's just a little video on how it works. So in here where we can pressurize the hood, I'll wait for it to go back. So what we can do here, we can open and close this venturi gap here. This will help us give an increased fill level, but we also have the ability to pressurize the hoods where we can control the boiling point. So what we can do is with a really low starch recipe, it gives the flexibility to maximize the expansion, but then control the boiling point as well to target density and achieve much lower densities. Here's a little bit more on the ECS. Obviously, we've got expansion, water boiling point, and what we can do is how the pressure accordingly affects boiling point. So obviously, if we have a temperature of 120 degrees, then we set the pressure at 2000 millibar. We can see how it affects the structure of the pellet coming out. So if we want a higher density, a lot more pressure, lower, gives a lot more expansion. So FlexTex and ECS combined, sinking fish feed, so optimization of the density. So we've got the die plate where we can do a lot of the work. So we can control 35 to 25% of the expansion on the die plate to the outlet here. But when we combine it with the FlexTex, we have a much larger range where we can control the expansion factor. So where we're only playing around with maybe 10% expansion here, we can play around with in excess of up to 25% expansion. So here's something I'll just leave you on. There's a little spoiler alert, so there's some new development to support the Sync in Aquafeed, and we will be launching this in 2026. All right, so yeah, still got 2 more, I believe. So at Andridge, we also have the ability to change the size of the die. So we have a system for the higher extruder output on the microfeed system. So what we can do is we can bolt this onto our extruder. This is an additional piece, an add-on, and what it does, it takes our working area of 52.7 millimeters squared all the way up to 73.5. So we can add an additional 40% additional working area. So obviously when we start looking at really small pellets and we're going down to the 0.6, obviously with a normal working area, we will lose capacity because we've lost the surface area. So what we've done now is obviously we've got the additional piece, so where we can still try and target higher capacities with lower. So a couple of take-home messages, sinking and floating aquafeed. So raw material selection influences the behaviour of the feed, floating and sinking. You know, we've all spoke about this morning. There are traditional ways to influence the floating and sinking behaviour, but the Andritz ECS and the FlexTex can aid you much better to achieve consistent great results. Pelleting can be used for sinking aquafeed, but extrusion gives you much more higher flexibility, being able to produce sinking and floating aquafeed with bigger, higher feed conversion rates, and I think that is what it is all about. A new development in the expansion control is on its way in Andritz, because we never stand still. And I think the final remark is Andritz can offer solutions from start to finish, designed accordingly to customer demands and the newest standards to ensure production of your aquafeed. If you want to visit us, we do have a booth 08K09. So if you've got any questions, please come down and speak to us this week, and we'll be happy to help. Thank you very much.
Thank you very much, Dr. Mian, for your nice introduction, and I'm glad to be here with you, and also happy to be the final speaker of this session. So that probably will give me some extra time to speak about things that I wanted to talk about. And of course, after all of this engineering and the specification and the high-tech talks that we've been through this morning, we are going to shift the topic a little bit to start talking about production systems and how can we feed the people and the sustainability. And I'm glad with the final, it caught my attention, the final remark from the last speaker, talking about the raw materials and its impact on the behavior of the behavior of the aquatic feed. Because I'm going to be mainly talking about the raw material, which is soybean meal, and how it is impacting or how it is participated to the revolutionizing of aquaculture industry globally. So this is going to be my title, Pod to Pond, the journey of from pod to pond, and how this have helped in revolutionizing the aquaculture with a special reference to US soy. Okay, the outline for my talk today will be about global fish production with a flavor of history, how it is advanced over the years, and with a special reference to aquaculture production trends, the drivers for success and progressive development of aquaculture, what has led to this progress and development, tremendous progress of aquaculture, then prospects and opportunities for growth and sustainability, because there is always a challenge when you get to a certain level of advancement. What's next? Where are you going to go next? Then conclude with advantages of US soy as a sustainable source of protein in aquafeeds. This demonstrates the journey of the story of fish resources, the development and production since the 1950s until the 2022. How this has progressed, where did it go? Of course, as we know, at the beginning of the past, the beginning from the 1950s to the 1980s, main contributor was coming from capture fisheries or wild fisheries. People would go fishing, and there was not enough people. There was enough supply for the wild fisheries to provide the needed fish protein for the population at that time. Then we started with the increasing demand. There was an increase of overfishing or the fishing pressure on the natural resources that we have. So they started to think about aquaculture. What could be an alternative source to increase fish production, trying to save this source that we have. Okay, since the beginning of the 80s, mid-80s, we started to see plateauing of the capture fisheries output, and then there has to be the alternative source, as I say, from aquaculture. If we look at numbers, this is showing how aquaculture started to emerge from the 1990s going up because since the mid-80s, there is a plateau over exploitation, or the natural fisheries has just started they became intolerable of any extra fishing pressures. 85% of the world fisheries fully or over exploited nowadays because of what we have. And as I said, wild fish capture relatively flat since the 1980s. And what this led us to think about, aquaculture is necessarily increasingly relied upon as the sustainable source of nutritious and affordable seafood. There is no doubt that everybody agrees seafood is the most nutritious, is a very good nutritional source, good protein source for human consumption. And of course, what this means that globally, aquaculture now provides more than 50% of all seafood for human consumption. This is what we see here. These red numbers are production from capture fisheries in 1 million tons globally. Until 2020, the two lines just met. Then aquaculture started to go over to provide more than 50%, and it is going to continue this way because this line is no longer going to go up. So the hope and the potential all comes from aquaculture. So there are challenges. There is a global demand and healthful food. Seafood is growing at unprecedented rates due to what are the reasons for this? There is a the global population is expected to be probably over 9.5 billions by 2050. There is a rising middle class in Asia and India and all over the world because people now are thinking of better food and better feeding habits. The people would like to consume good animal proteins or good proteins that help their health. As I said, wild caught fisheries cannot anymore meet this demand, and there is an additional about 41 million tons of fish per year need to maintain current consumption levels, just to maintain the current fish consumption levels, not even to increase it. And as I said, I mentioned about the exploitation or exploited of the natural resources. So aquaculture is increasingly relied upon to provide this sustainable. And I'm repeating this sentence again because it's just stressing how important aquaculture will be in covering this demand and closing this gap. But it has to progress in a sustainable way. How can we progress? What is meant by a sustainable aquaculture? Sustainable aquaculture, it must integrate the 3 dimensions of sustainable development: economic dimension, social dimension, and environmental dimensions, through addressing food security and climate challenges. According to the FAO, climate challenges, of course, we all are aware of the climate change and problems that we are facing, the global warming and climate change, and how this is impacting the natural resources. Then we have to start about thinking about climate smart aquaculture. What is climate smart aquaculture? It is a set of practices that sustainably increase productivity. We need to increase productivity in a sustainable way that does not harm the environment, that have resilient or adaptation, that is really well adapted to the changes that we are living at, reduce or remove the greenhouse gases emissions that everybody is talking about. What is the carbon footprint of anything that we eat or we produce or we use? Where is it originally coming from? We need to reduce that and we enhance the achievements of food security, global food security. We need to maintain global food security in a sustainable way through these practices. If we look at the three legs of sustainability in aquaculture, there are three main pillars: the hatchery technology, that's supply of larvae and fry, then the responsible management, and sustainable feeds. Through replacing, if we replace the wild-caught fish meal and fish oils with alternative proteins such as soybeans, that will ease the pressure upon ocean resources. Feed research has resulted in new formulations. We've been listening in the morning, and new technologies were developed to produce the best feed characteristics, whether it's floating, whether it's sinking or semi-sinking or whatever. These and how can cooking and extrusion enhance the digestibility of the fish feeds that we are using to feed our fish in aquaculture systems. Soy-based feeds are more affordable for aquaculture operators than fish meal and fish oil because of the cost. Of course, the cost of fish meal and fish oil is going up. Soybean meal is an affordable. When I'm saying soybean here, I'm talking about soybean in general, regardless of its origin. But there are certain differentiators between different origins that we will come to through my presentation, so we can scale up to meet demand for a growing global aquaculture industry. So this is just in a nutshell how we can see the pillars or the legs of sustainable aquaculture. As we know, feed accounts for the majority of production costs on aquaculture farms. From 50, some people even, they used to say 45 or whatever, but actually it is 50 or even 55 to 70% of the operating costs. Here we are just using the cost to express the importance of feeds in aquaculture. It's not just to talk about the cost, it is so much cost. No, it is very, very important component or constituent of the whole industry, the whole aquaculture sector. Because it's too much of the investment, so we have to pay very special attention to the fish feed. And of course, the use of high quality feeds and good feed management are essential for the success of any aquaculture business. Okay, why US soy? I'm talking here, I'm trying to convey, to deliver a message about the importance of US soy. Research and economic analysis by many firms like Witaya Aqua, they demonstrated great profitability and lower carbon footprint for aquaculture producers who choose soybean meal, US soybean meal made from US origin over soybeans from other origins. There are reasons for that. The studies show that, and why we are talking about this. Also, there was another, I think when Dr. Riaz started his talk in the morning, he was talking about the consistency, even in the processing and the manufacturing of feed. Consistency is a major characteristic that we should have in the feed. For US soybean, one of the major advantages is its consistency and sustainability. So, having a consistent product like US soy compared to other origins, and when it is very good advantage of the US soy. What we see here, this study compared 3 diets or 4 diets using USA soybean meal from Argentinian soybean meal, and Brazilian soybean meal. If we look at the cost here, there was not much difference in the costs the expenses on how to formulate a diet with this specification of protein content for tilapia. But look at these. These are the carbon dioxide equivalent per metric ton of feed produced. You can see this is a real hidden cost. It is a cost that is impacting the environment and environmental integrity, trying to move from being a smart to less smarter activity. You see the heavy impact on the environment that you use by using other sources of soybean rather as compared to the American soybean meal. So ultimate value of soybean meal is measured by more than just crude protein, because if we look at here, crude protein is very much close, but what's in there? There is digestibility, there is consistency, there is other the carbon footprint, and the environmental impact of these different products. So these are, and consistency, these are things, of course, heat damage. If you look at the specs for the different soybean from different origins, you can see why we are talking about the US soybean as an advantageous or as a superior. It has many better characteristics and advantages compared to other two main sources. There are many other sources of soybean, but I think these are the three major soybean producers in the world: US, Brazil, and Argentina. So what US soy has characteristics. There is lower total damage. US soy is 5 times lower in total damage and heat damage when compared to soybean from other origins. That means it is only 20% of the total damage or heat damage when compared with soy from other sources like Argentinian or Brazilian. Also, heat damage decreases the digestibility of calories and essential amino acids, and lowers the consistency of the nutrient composition. So, US soy is characterized by lower heat damage and lower total damage. Also, some of the benefits that are associated with using US soy, this is one of the products that US soy delivers solutions to business partners, like this IAFFD database. This is the International Aquaculture Feed Formulation Database that is free for everybody, for anybody to use to best formulate his diet using different ingredients, whether it's US soy or Brazilian or Argentinian, sorry, Ukrainian or anything. All the ingredients, all the raw materials, the vitamin, additives, anything, this is being funded and developed and being made available by US soy. Okay. Some of the researches, some of the results that were shown that growth of tilapia fed diets with increasing levels of soybean meal from different origins, showing better growth rate with, this is the US, the Argentinians, the blue one, Brazilians, and the green one is the American US soy. It is always on the top of the other two origins of soy when you're comparing for growth rate, daily growth rate, concentration, and crude protein diet with the different levels of crude protein. Then if you look further for the feed efficiency, because it's not always just amount of feed, but it is amount of gain on fish that you get when using equal amounts of feed. The feed efficiency here again for US is well over the other two sources, whether it's Brazilian or Argentinians, at the same crude protein levels, but feed efficiency is better for American soybean origin. When it comes to filleting, when you are looking for adding some doing some processing and filleting, because sometimes you can produce masses of fish, but the dressing percentage, the amount of muscles or protein that you can get is better. It is what differentiates between different fishes. Fishes with higher fillet yield definitely are better than those with low fillet yields. And this is showing here that US soy meal supported the best fillet yield in tilapia. If we can see it here again, all the three curves are all the figures that I've shown previously, showing always the US soy origin is coming on the top of the other two origins. And of course, these studies were done independently by institutes or partners that do the work, and we get the results and try to illustrate why US soy is better when compared to other sources, because also there are benefits that you can get. Sometimes you can formulate with a lower price, but what is the cost of having less growth? What is the cost of having less filleting percentages? What is the cost of having bad environmental impact or higher carbon footprint with using different sources? So these are things that you have also, we need to calculate, we need to estimate how much charge, how much expenses are we paying for this. It's not just tilapia, but also for shrimp. When you're looking for shrimps, again, you see, of course, this is the cost. US, or even the US diets of US origin are cheaper less costly than other two origins. It's not much, but with this multiplying by the volumes, the huge amounts of feed that's being used, a feed manufacturer can make a lot of money using those, even if it is only $2 or $3 per ton. Whatever, you can make savings of millions of dollars from adopting this, besides the carbon footprint that you can see from using the other sources. If you look at economic indicators, here are the profit margins from US soy, Argentinian soy, and Brazilian soy. This is 22% profit margin versus 19.3 and 18%. So again, US soy has the best profit margin raising shrimp utilizing for these purposes. Another example showing the price and greenhouse emissions for the feeds from different sources for different protein levels. You can see here again the diets and the carbon footprint for these diets. And these are the margins, the economic margin, the profit margins, 13%, 9%, and 5%. If the profit margins that are generated using these different sources of different origins of soybeans in the diet. Again, for another trial for shrimp, So this is what I talked about earlier. And just this is something that I need to conclude with, just to the takeaway message. Feed accounts for the majority of the production, and the use of high quality feeds, whether it is from any origin, and good management of the feed are essential for the success of an aquaculture business. And thank you very much.